Now we're going to look at a more advanced use of GraphMaster dealing with first and second derivatives. So let's type in an equation. Y equals 1/12 x to the fourth plus 1/3 x cubed minus 4x squared minus 4x plus 30. This is a fourth degree equation that should resemble a W shape once it's plotted out. Note how the fractions are entered and no multiplication signs are required. And just hovering over the field allows them to convert into the proper formatting. I'm going to click OK, plot the equations. Now, we're not seeing the entire expected W shape. Many of the significant features of this equation are actually outside of our view. So let's get the maximum and minimum points to give guidance to the required axis limits. So we're just going to hover over the graph, right-click, points of interest, max and min. And now you can see one of those points plotted on the graph. We're going to go up to points and labels, and we can see that there's 3 points that have been identified, and we want to look at the values, and we can see that the largest y value is 31 and that the smallest y value is negative 55.8. So let's go back to the graph, click on axis limits icon, and we're going to change the y-axis limits to 40 and minus 60 with 10 intervals. And now we can see the entire W shape. So now let's find the first derivative. All we have to do is return to the Equations tab. We're going to make sure that that equation is selected. You can see that it's selected because the black dot appears, and we're going to copy that active equation down to the grayed out field. And after that, we are going to, that allows us to store our red equation. So now we're going to click Paste Equation to Equation Bank. That makes the Equation Bank window appear. And notice that the equation is placed into the new equation form. And if you need to edit it, you can do that within that form. However, what we'd like to show you next is the Convert to Derivative feature. So all you have to do is click that Convert to Derivative. And as you can see, we have an equation there, but there are a lot of brackets showing in that equation. And so we've added a couple new features to the program, and we'll show you how to use the Allow Bracket Reduction feature. So simply by clicking on the checkbox and then moving the mouse back into and then out of the equation field, all of the unnecessary brackets are automatically removed. We can also edit the 0.3 repeated to be 1/3 to tidy it up a little bit more. And then we'll click OK. So now we're going to plot the equations. And we can see in green the first derivative equation, which is y equals 1/3 x cubed plus x squared minus 8x minus 4. So let's get the x-intercepts of the green equation. Again, we just hover over the graph, right-click, x-intercept, and there they are. Now notice each intercept has an x value corresponding to the x value of the max or min values of the red graph. So on the left there, you can see in green minus 6.4, and going down to the red graph minus 6.4 again, we can see appearing. And we can also see the same thing happening here, minus 0.5 and minus 0.5, and then over to the right here we have 3.9 and 3.9. If we'd like, we can also zoom in more to see those points more closely. We just have to click zoom mode, select an area. You can select it really as many times as you want to get additional detail, and you can see that there's more decimal points appearing each time you do that. Okay, so let's go one step further and get the derivative of the green graph, which will be the second derivative of the red graph. So there you see it, y equals x squared plus 2x minus 8, and we're going to plot that. And there it is. So let's get the x-intercepts of this second derivative blue graph. And there they are. You can see minus 4 and 2. So what do these values correspond to? Well, obviously they correspond to the x values of the max and min points on the green graph. But more importantly, they correspond to the x values of the inflection points of the original red graph. Let's take a look at that. And there we have them. So to summarize, x-intercepts of first and second derivative equations correspond to max and min points and to inflection points. Now you might want to try another equation yourself. And remember, you can download a free sample of GraphMaster from graphmaster.ca. Just hit the request button and follow the steps. And you can try out a full version of the software yourself. If you'd like to try out this equation, then you can give yourself a challenge. So this new equation is y equals 1/4 x to the 4th plus 5/6 x cubed minus 23/2 x squared minus 12x plus 20. So give that one a shot. There you have it. And enjoy, and remember to go to graphmaster.ca and download your free trial copy. Let's just save this one as sample 6.